Great. Welcome to those who have made it here so far. We're just going to give it another minute for people to join and then we'll get started. All right, I think we have a good amount of people now. So welcome everyone. My name is Caitlin. I'm the programs coordinator at Urban Green. And I just want to go over just a few things. One, if this is your first webinar with us, we do ask that you submit any questions during the presentation in the Q&A box. We ask that you submit it there and not the chat, just so that it's easier for our moderator to review your questions as they come in and make sure we don't miss anything. If you do have any technical questions or technical issues during the webinar, you can email me at kl@urbangreencouncil.org and I'll get that sorted for you. I also want to take a minute before today's discussion to review Urban Green's values to set the tone for today's discussion. Urban Green uses these organizational values to guide our work, and as a part of our commitment to fostering inclusive and respectful dialogue, we do ask that all meeting participants are mindful of these values during the discussion. And with that, I'm going to turn it over to John Mandyke to do a little welcome today.
Caitlin, thank you very much. Good morning and welcome to everybody. My name is John Mandyke. I am the CEO of Urban Green. I want to thank you for joining this really important discussion today. As we continue to focus more on electrification, the issue of grid resiliency becomes ever more important. And so this is an ideal time to have this discussion today. So we're thrilled to do it. I want to thank Con Ed for being our sponsor for today's discussion. Con Ed has been a longtime supporter and collaborator and partner with Urban Green. We appreciate all their support and what they've done to make this discussion possible today. So let's get right to it. I hope you enjoy the program. Let me turn it over to Danielle Manley, Urban Green's Manager of Policy, to take it from here.
Hi, everyone. Thanks, John. Thanks, everyone, for joining us here today. And I'm excited to welcome you to our panel discussion on grid resiliency in New York City. As John was just saying, it's a really interesting topic because we all know that there are increasing demands on the utility grid to provide reliable and continuous electricity while simultaneously meeting the targets that reduce our carbon footprint and provide increased load for the electrification of buildings and electric vehicles. And all of this needs to be planned for in the face of things like climate extremes and other events that risk causing power outages to customers. So we have three really exciting and knowledgeable panelists with us today from Con Ed, who are going to talk us through how the grid is evolving to meet these challenges. We're going to talk about what opportunities utility scale storage can provide and what solutions are available for customers to reduce demands on the electricity grid. So we have Jared Trumpetto, who's project manager for distribution planning and market integration at Con Edison. We have Mohamed Kamaludeen, who is project manager for energy storage distribution planning, and Lindsay O'Neill-Caffrey, who is program manager for the Non-Wires Solutions Demand Management Program. So we're going to kick things off with a brief presentation from our guests today, and then open up the majority of our time for discussion with the panelists. As Caitlin said, we invite you to please type any questions that you have into the Q&A box. And I believe there's also a feature you can use to upvote other questions. So feel free to use that too to let us know what you're really interested in hearing about. And with that, I will turn it over to you, Jared.
Thank you very much, Danielle. And thank you for giving us the opportunity to share some of the exciting work that we're doing to prepare the electric grid for our clean energy future. If we want to start with the agenda slide. So we're going to talk through some of the goals, challenges, and solutions that Con Edison are considering for a future that relies on the electric grid like never before. We'll start by going over some goals and impacts before we transition into my colleagues Mo and Lindsay who will go over our energy storage future and how we employ customer-sided solutions and some third-party solutions, as well as our energy storage packages to meet longer-term grid challenges. So we can get right into it. So we're in the most significant period of grid evolution in decades. It's driven by an increased reliance on the grid, as well as targeted goals from the Climate Leadership and Consumer Protection Act, as I'm sure most on the webinar are familiar with. The Act codifies goals of things like 70% renewable generation by 2030 and 100% by 2040, 850,000 zero emissions vehicles by 2025, 6,000 megawatts of distributed solar by 2025, 1,500 megawatts of storage by 2025 and 3,000 megawatts by 2030, as well as things like 9,000 megawatts of offshore wind, which would be directly connected into the greater New York City area. As you can see from the pie chart on the right, many of the targets are directly applicable to the percentage share of carbon production driven by electric generation in the transportation sector. At Con Ed, though, we also understand the role that our customers play as well. That's the additional, roughly 30% there that's made up of industrial, residential, and commercial. And we understand that all these changes will have, significant impact on the end-use customer as well. We also are engaging in things like our storm hardening efforts to reinforce our networks, and we have worked on advanced grid management tools to better communicate with the grid edge and gain a better understanding of our operational needs. We've undertaken a climate change and resiliency study to understand the true constraints that the future climate and our changing environment will present to the electric grid. And we understand that new requirements on our end-use customers, as well as an evolving ability for customers to become more sophisticated participants in their own energy future, will drive us to more flexible solutions for communications and operations within our network areas. And we're going to need that sophistication because, as we'll see on the next slide, electrification in these areas will significantly drive electric loads, specifically in our winter months, perhaps doubling our peak system load and shifting that load to the winter. Traditionally, cooler months are where we reserve space on the system for system work and construction. So the creation of a winter peaking system will reduce outage windows and make it more difficult to perform traditional system maintenance in order for us to kind of catch up to the evolving grid needs and prepare the infrastructure necessary to meet the full scale of decarbonization as we head out to 2050. So these changes require an increase in system flexibility, both from a planning and an operations standpoint, and we need to reconsider the way that we're able to leverage the grid, both for the customer need as well as the utility need as well, so that we can all meet these goals in unison as we move into the future. And it's with that idea of an increasing need for planning and operational flexibility, I think that our next two presenters are really going to get into and kind of demonstrate how we're thinking about creating that flexibility, both from the utility side as well as the customer side, to be able to manage these significant challenges as we move forward into what is a certain future in terms of the goals that we want to achieve, but mostly an uncertain future in terms of the way that we can continue to leverage newer technologies and grid development to get there. And so I'll turn it over to Mo, who's going to illustrate one way that we're going to achieve this operational flexibility.
Thanks, Jared. And keeping along operational flexibility and overall flexibility of how the grid is evolving, energy storage certainly play a critical role with that. Given the nascent nature of the technology in itself, the ability to complement other DERs are really unique features that help storage be a critical part of our planning tool and a critical asset that needs to be integrated into our distribution and bulk system architecture. That being the case, we are investing a significant amount of time and money to deploy these systems. The way we think about energy storage in the grid is really around three buckets. On the bulk system, the distribution system, and the customers, recognizing that all three have a very important stake at the table to achieve the CLCPA targets that Jared mentioned a few seconds ago. In terms of bulk, grid application is very important. It really helps with transmission capacity. It helps with peaker plant alternative, certainly around GHG emissions and NOx emission, getting to certain compliance standards, especially around DEC new rules for New York City. And then more importantly, continue to do what general GTs and transmission system turbines does in ancillary markets to provide additional revenue for customers. In the grid, I'll talk about a little bit more on these highlighted in the red box in subsequent slide. But distribution support is also critical, as the lower downstream you go, the benefits actually trickle up, and enabling distribution capacity, renewable integration, supporting our power quality of the grid, and really leveraging inverters for volt-var optimization are really key things that we look to carve out value for. Renewable integration also, especially around solar and wind, is critical. Solar specifically, as we're starting to see in certain areas in our territory, having storage to support or emergent duct curves is critical, as these antiquated or old substation equipment cannot really handle the strain as you get into certain ramp up or the neck of that duct. On the customer side, we are engaging in several projects. I know Lindsay will talk about NWS, so I won't spend any time on that at all. But we are engaging in various demonstration projects that really test mobile storage. How do we support our grid during contingency? And then innovative ways of aggregating solar and storage and virtual power plants, and then redistribute those benefits to our customers as we support the distribution system, but more importantly, earn revenue in the New York ISO market, and then re-socialize that to our customers, especially in low to moderate income, where we're actually putting a lot of energy and time in going forward. Next slide. So what are we doing on our distribution system? As we stand today, the picture on the far left is our 98th Street battery in Ozone Park. That's a 2 megawatt, 11 megawatt hour system that is in service, that has supported the grid for the past 2 summers, more recently supported both distribution and transmission contingency. And this summer, we're actually hoping to put this asset into the New York ISO market and help test additional functionality and grid services that are needed for our customer benefits in this Bqdm load pocket. Picture in the center is a future site in Staten Island for a system, a 7.5 megawatt system that will be supporting our substation to help with renewable integration, as well as providing critical grid support during summer and summer contingency. The system to the far right is our Nevin Street charging hub, or make-ready model, where we actually opened our property that doesn't house critical infrastructure for third-party owned energy storage and EV charging. This site is also scheduled to come online next year, and about a tremendous amount of opportunities for developers or third-party in general to provide customer-sided solutions that not only enable grid resiliency, but also carve out a market space for third party to play in a utility landscape that aim towards helping these CLCPA goals. I'll take more questions on this later, but certainly looking forward to this discussion. I'll pass it over to Lindsay.
Thanks, Mo. So one of the programs that Con Edison is pretty proud to be running right now is called the Non-Wire Solutions Program. And it's a portfolio similar to how we discussed customer-sided solutions of demand-side reduction projects that cost-effectively defer or eliminate electric system upgrades at the distribution level. So that means that we're assisting in both helping meet New York State REV goals and CLCPA, but also being integrated to our utility planning process. We're actually offsetting or eliminating different types of traditional upgrades. So we're currently operating 3 active portfolios. They can be seen on the map here. So it's a pretty large swath of both Brooklyn and Queens. The first, I think, is probably the most well-known, is the Bqdm program. So this was designed to actually defer an entire substation. And that is a program that commenced in 2014, was extended in 2018, and that we are continuing to run today. Our second program is the Water Street program, and that was designed to actually eliminate a project that was designed for cooling and reconductoring. We are kind of closing that out right now, but effectively that's a program that's run for the last 3 years. And then we have our third program, which is the Newtown Program, which was designed to defer a transfer from the Newtown substation to North Queens, which commenced in 2019 and is going to continue to defer the need for any type of real growth there from the utility side through at least 2025. And all of these are going to be met with customer-sided solutions, which on the next slide I'll get into. And so really what we're trying to do within the Non-Wire Solutions program is meet customers where they are, whether that's residential or more sophisticated customers who are looking to sort of deploy fuel cells, CHP, or energy storage. And we do that through really taking a look at all the different sort of market verticals that our customers sort of exist within. So that can be either providing them with energy efficiency measures. We have a neighborhood program where we actually went sort of door to door and offered people an opportunity to receive free LED upgrades, all the way up to sort of large scale commercial grade battery storage, which is under 5 megawatts. But we have a mall that has a 4.8 megawatt system sited there right now. So it's really understanding how we can create a cost-effective portfolio that helps customers both leverage technologies that maybe they're already familiar with, but need some capital assistance in delivering on because maybe they're early adopters of that technology, or enable them to provide backup power in the form of CHP or fuel cells for some of our more critical customers, including hospitals or various types of medical clinics. So happy to discuss each of those individual portfolios and which of these offerings exist within them. But thank you for your time.
That was great. Thanks so much to the three of you for giving us a good overview to get us started in our conversation today. So I just want to remind everybody that there's a Q&A function. So please type any questions that you have for our panelists into that Q&A, and we can get talking about whatever you're interested about. But I'm going to kick us off with a first question for Jared. You mentioned that Con Edison had performed a climate vulnerability study and a climate resiliency planning report. How are you using the climate forecasts that you found in the climate vulnerability study to plan for grid resiliency to the physical infrastructure that's at risk from climate extremes like coastal storms and extreme heat, and also to the increases in demand that are going to come with more frequent and intense heat waves?
Yeah, sure. So it certainly presents its own separate issues on top of the need to serve an increasing amount of electric load, as was shown on one of the earlier slides. We did a lot of effort in benchmarking in concert with areas that had already looked at this. So New York City had done a climate resiliency study. The state of New York had looked at climate resiliency. We've known for quite some time from a storm hardening perspective that there was significant amount of grid modernization that was going to be needed to meet new storm challenges that we started to see even as far back as 2011, where some winter storms became not only more frequent, but a little bit more destructive in our overhead territories, as well as the results that we saw in 2012 from Hurricane Sandy. That was devastation in our New York City borough areas that had just never been seen before. So we had already been in tune with the fact that a different approach to grid resiliency was going to be required, simply from some of the experiences that we had throughout the mid 2000s. But when we really sat down and looked at it, we kind of looked at it in two parts: temperature, as well as weather events. And the idea that for every piece of infrastructure that we would be installing, or every new megawatt of load that we would be looking to meet from a load standpoint, would we actually be able to serve that in the future if the dynamics of the way that we're planning now changed? And so from a storm hardening standpoint, we looked at a lot of things like obviously increased weather events and the need to be a little bit more flexible in system restoration. We looked at things that New York City was already looking at in terms of construction standards and the ability to site equipment perhaps a little bit higher in floodplains because of the increase in coastal flooding that we will potentially see as climate risks increase in the future. And then we looked at the way that we plan the system from a temperature variable standpoint. The way that we look at future planning is we kind of adjust to a temperature variable that takes into account both true temperature as well as humidity, as well as the thermal stress that the equipment actually sees from the load serving capacity as well as the temperature. And we looked at whether or not that still made sense for a future where we would be seeing more extreme heat events. And I think what we saw is that the actual planning metric probably still holds true. But what we do see is the need to be able to withstand that metric for an increased amount of days a year in the future. And we looked at a lot of bookend scenarios. We took, temperature readings from areas like Central Park and JFK Airport, and we kind of put them into a probabilistic model to see, okay, today we may see 10 temperature variable index days that push our design criteria today. In the future, what if we saw 20? What if we saw 30? Does that change the need to future-proof against those when we're doing construction today? And I think what we found is that the answer is yes. And so when we take on new projects and we look at meeting system demands in the future, not only are we looking at, the ability to meet that capacity when that capacity shows up, but the ability to meet that capacity under greater and greater environmental stresses as we move closer towards the 2050 goals from the CLCPA.
That's a great answer. Thanks. And there's a question we have in the chat in relation to maybe, I guess, a technical question related to when was the season peak in the past? Was the season peak always in the summer, or 20 to 30 years ago? Someone suggests that they thought that the winter was the historical peak.
So if you go back further, if you go back to the 50s, 60s, and 70s, where you had a higher prevalence of electricity being used in the home, things like, we have Edison, we have a lot of these like historical scrapbooks that you can find in our library that takes out like ads that the company used to have. And when you look at some of the appliances that were advertised for the home, electric stoves, electric popcorn makers, electric ice cream freezers, waffle makers, things that were pretty prevalent in folks' homes before, adding to the fact that AC use really wasn't as prevalent as it is today. The peaks were a lot closer in past years, simply because the usage dynamics were more or less a little bit more even between the winter and the summer. But as our load growth increased, very much so into the 80s, 90s, and 2000s, and AC became more or less something that most people had in their homes, whether it was central air or it was a window unit. And natural gas was able to drive down the usage of a lot of those typically electrical appliances in the home. You saw a pretty significant deviation where up until REVs started in 2015, summer loads were anticipated to increase at a pretty rapid rate, whereas the winter loads had more or less evened out. And what we see now is a total switch in the dynamics because of energy efficiency and the demand response measures that Lindsay touched on in the non-wire solutions section. We were able to more or less predict a very gradual summer growth in terms of the usage out into the future. A lot of modern technologies and the gains we've made in efficiency kind of saw pretty much even loads. Whereas now, when you factor in the transition off of natural gas for things like heating, and you add the zero emission vehicle load from an electric charging standpoint, and you homogenize that out over the year for usage, you start to see that hockey stick that was presented on the earlier slide, where now the winter peak will significantly outpace the summer peak in ways that the summer peak never was able to outpace the winter peak. So that's kind of shows you the amount of not only significant change in the future that we're going to kind of see, but the rate of change that will really pick up. We're forecasting pretty heavily after the 2035 timeframe.
Mm-hmm. Yeah, interesting. And you brought up something interesting in your response a little earlier too, that you're not only planning for these maybe increases in summer extreme temperatures or summer storms, but we're still paying attention to the winter. It's not like our winters are going to be really warm all the time, and we still do have these winter storms that might come and have extreme cold snaps where people might be requiring increased heating during the winter months too. So it's important to keep both climate extremes at all times of the year in mind. And it's interesting to see how those have changed over time with the technology that people are using and putting those demands on the grid. I just want to make sure if we have any questions still on this. I'm just checking the chat really quick. So I'm going to move just a little bit to Mo right now. In light of what Jared was just talking about and these increased demands, why is large scale storage so important to improving the reliability and resiliency of the electricity grid as we move forward in time? And what kind of capacity do we have right now? And do you see that capacity of storage increasing into the future in the next few years?
Yeah, that's a great question, and something that we've spent a tremendous amount of time really strategizing on how we actually target our investment, target our incentives, and where do we strategize from a deployment perspective. As it relates to reliability and resiliency, storage is critical to that as we think about CLCPA goals apart from just the renewable asset or renewable targets. Talks about wind, talks about solar, and having large scale battery really look to potentially deload and unbottle some of the interconnection constraint associated with bringing those renewables to the system. We also need to support these renewables because the grid, as you think about a large deployment of solar, you'll see this huge duck curve starting to develop. As you think about large integration of wind from offshore, onshore, or even in some parts, rooftop windmills are starting to become prevalent. How do you really think about that level of intermittency and response? And storage provides that level of quick seconds response to these demands, and when paired or integrated strategically into the grid on a larger scale, could potentially provide support to counterattack that response and absorb some of the reactive power that is being injected consciously or subconsciously. We also look to support in-city peakers, given the recent DC standards around NOx emissions starting in 2025 during high ozone days. Some of these plants that we have throughout our city will be in non-compliance. Energy storage will help during those long duration hours or short duration hours to allow these peakers to ride through those high ozone days during those hours, so we're not polluting or contributing to this NOx and SOx emission standards. So that's been really looked at to bring us into compliance, as well as ultimately as we deploy hundreds of megawatts of this, potentially replacing these peakers. And last but not least, really think about how we could actually have customers be part of the solution and not just utilities. There's a lot of discussion about outdoor storage, and I saw in the chat, and I'm going to jump a little bit to address that question here. The conversation is surrounding, what happens in rooftop storage? What incentives are we providing outside of the normal NYSERDA incentives and so forth? Couple of considerations while we do have, and Lindsay could talk better to this than me, experience with rooftop storage. Some consideration that needs to be accounted for is scale, size, and form factor and density. And density from a strictly weight perspective. A lot of these buildings were not designed to accommodate some of these energy storage containers. And as we talk about larger deployment and not just the kilowatt, but megawatts, how do we ensure that we have that amount of structural integrity to handle these container size storage? And how do we aggregate them to deploy in a meaningful way that supports the grid? And aggregation is key. 4 quarter 222 really stems on aggregation and dispatch. So one of the things that we're doing from incentives, and this is more on Lindsay's side, but I'll touch on that, is really opening up some of our properties to deploy storage. And Lindsay have actually some really good programs around residential storage that she's incentivized. But incentives comes in areas of constraint at the moment. We're looking to potentially see if that could be expanded, but nonetheless, we need to make sure that our investment makes sense for our ratepayers. And that's how we tackle that going forward. Your second question talked about how much megawatts do we have, what our projection going forward. As we stand today, I had a chance to pull some metrics. We have, from a utility perspective, about 2 megawatt that is employed and that is installed and deployed. But nonetheless, we do have, as you think about storage in general, about 10.5 megawatt currently deployed in New York City, and across our service territory, about 14.6 megawatt of storage. Nonetheless, it's a very optimistic future. And I could safely say that we have a very large in-queue of solar that is pending to come online by 2022 and 2025. Con Ed in specific have as much as 112 megawatt scheduled to come online by 2022, and rapidly scaling that up to 248 megawatt by 2025. As it relates to all things storage in New York State, we're seeing a rapid increase of as much as 345 megawatts by 2025, for in-queue connections that are currently in our books and we're currently assessing.
That's great. Thanks, Mo. And Lindsay, do you want to pick up on that and talk about any of the incentives that are available for storage?
Sure. I guess Mo appropriately pointed out that right now our current incentives, at least through non-wires, are centralized in areas where we actually have a distribution project that we're looking to either eliminate or defer. And I think, you know, one of the interesting components about working with storage is, as Mo pointed to, there's a lot of different complexities associated with it, right? So we're actually very happy that we were able to install one of the first lithium-ion storage systems on a rooftop, but that took many years because we had to do sort of heat flux analysis on all the buildings that are surrounding that. Depending on the sort of infrastructure that you have in place already, you might need electrical service upgrades through interconnection. You might have to do roof reinforcements, and all of that sort of combined creates a project cost that may not pencil initially, right? And that's what a lot of the sort of NYSERDA and Con Ed storage incentives are there to help move along. Sometimes the capital and the upfront requirements for storage are quite high. So that's sort of where we're trying to go with storage now, keeping in mind that, you know, we do have very sort of lofty state and local goals. And I know the city has been very active and supportive in helping us, at least at Con Edison, push that along and make sure that we have proof of concepts that we can use to then go back out to customers and say, here's a case study of how, you know, we helped this customer shift their peak demand, and through energy arbitrage, they actually have a revenue source. And we've driven down their sort of simple payback period to a point where, you know, with the Con Ed incentive, we have a 10-year contract and the customer is actually going to be able to benefit for many years after that. So I think a lot of that is going to be sort of continuing to move forward. But a lot of it is also making sure that we have customers who understand the value that it actually produces for them. So that's one of the things with non-wires. You know, we try to both have customers come to us, but we also try to put out incentives for energy efficiency, which is a little bit of an easier technology to understand sort of upfront. And that sort of is a bridge as people think a little bit more about both their current and also future state of energy consumption and you know, control. I mean, I think Mo pointed this out, but batteries in a lot of ways provide control for customers. And that's something that we're seeing, you know, a growing number of at least larger commercial customers really be interested in.
That's great. Thank you. And then I think there's one question here that I think relates to the topic still of storage. There's a question: City Council is pressing for a study to determine the feasibility of replacing Astoria's peaker plants with batteries. How does that fit into your planning at Con Edison?
Yeah, I can take that one. So as it relates to Astoria peakers, peakers in general are in the hundreds of megawatts. I think there's a couple of things that are critical to potentially replace peaker, or part of the equations to replace peaker. One, cost; two, interconnection; and three, economies of scale. Cost from not just a battery cost for building a battery or ensuring a certain level of performance, but cost associated with balance of plant. Having available land, whether it's greenfield or brownfield property, especially brownfield in New York City, is not easy to deploy on because of remediation concerns and so forth. So that plays a big role in the cost. Interconnection also makes a critical bottleneck, because in city peaker, while they're able to provide a certain amount of megawatts, for lack of better words, or power, contrary, battery requires that same amount of power or similar amount of power to recharge. And that poses a significant struggle or potential bottleneck, especially on the transmission system. So as you think about larger scale batteries in hundreds of megawatts, that is something that we're currently trying to tackle. And that requires some significant investment from an infrastructure upgrade. Happy to report, though, that we recently signed a deal with 174 Global to deploy 100 megawatt of storage at the old Paletti site, which is right around the Astoria complex. And that is our first step to really work with third-party developers as we break these barriers down to deploy larger scale storage to support these in-city peakers. We're also going to get ready to do another solicitation for another 200 megawatt. Hopefully we'll get more to support similar deployments such as that 100 megawatt, but overall replacing these peakers. So hopefully that answered that question.
Yeah, I think so. Thanks. I'm going to turn the topic a little bit. We have a question that relates to electrification. So one thing is, as I think we all know, as more and more buildings start to electrify around the city, it may place increasing demands on the grid, possibly in different pockets around the city. How are you tracking the rate of beneficial electrification in buildings and helping to adapt to the demands that heat pumps are putting on the grid?
Yeah, sure. I can go ahead and take that one, Danielle. So, as I mentioned earlier, we are fully aware that the stress on the grid and the need for grid evolution is kind of it's peaking here, and it's greater than it has ever been before. What we've started to do, more or less, is we're factoring in the CLCPA goals right into our planning efforts. So, we are making assumptions today that the state meets each and every one of its CLCPA goals, and we're factoring those goals into our distribution planning activities today. I think to build off a little bit of what Mo had mentioned about the peakers, because I think it's all sort of tied together in the way that we're looking at planning. There was an effort that was kicked off last summer by DPS staff. It was the Transmission Planning Working Group, which was part of the Accelerated Renewables Benefit Act, where all of the utilities got together and we kind of looked at reasonable assumptions that the New York Independent System Operator had made around what it would need to take from a generation standpoint to be able to meet 70% generation by 2030 and 100% generation by 2040. And from those assumptions, we all did coordinated studies that kind of looked at what the topology of our areas would look like. And obviously, Con Edison is a little bit more unique than some of the upstate utilities because of our load dynamics, and our load density is so great that obviously electrification plays a much greater role in our area than in some of the other utility footprints. So a lot of our study that we had done over the course of 2020 and into 2021 was to identify beneficial projects that would be able to not only meet the capacity of the growing grid in New York City, but be able to utilize a lot of the generation that would be created from upstate areas and get that generation into our service territory. So we can kind of do two things at the same time. We can help meet the overall proliferation of renewables throughout the state, and we can have a home for the generation that those renewables are creating for us, as well as opening up some of our load pockets in New York City to be able to, to better serve that load with sources from outside the city and create some of that bi-directional, power exchange that's going to be needed to meet, some of the broader statewide goals. So for us, it's kind of like a 5-year at a time type plan. We file a distribution system implementation plan every 2 years. That's kind of our 5-year snapshot at what is more or less going to end up in our most recent rate case. So what we're doing in our rate case planning to address near-term needs. And then we go all the way up to our electric long range plan, which will be published later this year, where we take that 20 and 30-year look at, okay, how do all these kind of 5-year planning blocks over the next 20 or 30 years kind of create the full package of investment and activities necessary to be able to meet those challenges, both from a generation and from a load serving standpoint.
Gotcha. Okay. Thank you. And then while we're talking about some things at the state level, if the state, as a part of the CLCPA planning, were to pose some type of mandate on all electric new construction, would that pose any challenges for distribution in New York City?
Certainly over the long term. But again, we're factoring that into the planning today. Our long-term planning scenarios essentially are now assuming that New York City is fully electrified by 2050, and that we're operating a carbon-free grid, and that we're serving that load based on the generation metrics that are also laid out in the CLCPA. So today's distribution planning scenarios are factoring that in as an endpoint. The CLCPA is a law. Those goals, in our opinion, are mandated legal benchmarks, and we're going to get there. And so that actually makes it pretty easy for us. We don't have to guess anymore where the load is going the same way that we did, maybe back in the early 2000s or even in the beginning of REV. We know where it's going because it's been codified in the CLCPA. So our planning scenarios become a little bit more deterministic. And in that respect, it's a little bit easier for us to create known projects because we know that we're now shooting for a benchmark that is is not going to change in any significant capacity, because we understand what the load would look like if everything, today from a transportation and a building standpoint, moved from, natural gas and gas to electrification.
Gotcha. And then Lindsay, I'd like to turn it back over to you for a second to help support these goals. Customers are wondering what they can do to help be a part of the solution, and what sorts of benefits do owners and maybe even tenants see from participating in some of the programs that Con Edison provides to reduce electricity demand and energy efficiency or distributed energy resources?
Sure. So I can say, and just sort of to dovetail off that last comment from Jared, one of the things that we're trying to plan for is both electrification, but also how to offset that on a distribution level. So that's what non-wire solutions does. But we also actually sit with a group called the non-pipe solutions under what's called targeted demand management. So should we end up in a situation where we see a massive amount of electrification in a certain area, where we potentially electrify an entire, neighborhood or a block or a specific type of, building typology of new construction, there are incentives both from Con Edison to do that, to support that adoption of technologies, to sort of help people move along the adoption curve and drive down the ROI to make a project, financially viable. But we also are planning for that on the electric side. And so because we're both sort of doing non-pipes and non-wires together, we sit in the same group to make sure that we have, appropriate planning going on. But I think one of the things that's important for customers to sort of understand, and specifically building owners, is what makes sense for them now, but also in light of a lot of the local law changes. So, if you walk around New York City, you can see sort of building grades, local law 97 is coming into play. Like, I think a lot of people are starting to think about how they can potentially invest now for a longer term energy vision for their own property, which is a little bit of a shift. I know typically a lot of buildings tend to do sort of like ongoing day-to-day maintenance, and how do we sort of just get through, this next capital planning cycle where maybe we need to redo, some HVAC system, but also we want to do the lobby. And I think people are starting to think a little bit more holistically about how to integrate both their current energy needs, but also their future energy needs, knowing that, their tenants are also interested in that. I mean, a lot of commercial tenants look to LEED buildings and other types of green certifications as a way to say, like, this building supports the values that I want to have. And I think things that are of benefit, I mean, specifically within demand management, we sort of promote peak shifting. Through energy arbitrage, you can sort of have demand charge reduction, you can participate in demand response. And so a lot of the sort of demand management tactics that we sort of work with customers to employ actually have revenue benefits on an ongoing basis. And that's sort of the play of, BMS controls, energy storage, fuel cells, CHP, but there's also energy efficiency. And Con Ed has a massive energy efficiency department that sort of helps customers and tenants both save energy, but also help them meet their own potential, either energy or climate goals. And a lot of that is through, LED upgrades. It can be as simple as sort of swapping out bulbs, or, we want to do an entire chiller overhaul. So it's, I think, a lot about sort of discussing with customers what their current needs are, but what also their planning cycles are. I know the typical sort of single versus 5-year capital planning cycle for at least a commercial building sort of happens in the fall. How do we talk to them at that point to make them aware of how Con Edison can financially support that, but also educate them on how they can both meet local laws and also meet their own goals moving forward?
Yeah, and that's going to be really important for buildings to understand. Starting not only this year with energy grades, but like you said, in 2024, as the carbon caps start to go into effect from local law 97. And a lot of these solutions that could also help, they could help reduce their carbon footprint of their buildings, and they can also use them to deduct from their overall building emissions. So it's good to see that kind of support from the utility. This may be a question, I'm not sure, Lindsay or Mo, who's better to answer this, but this is a bit more of a technical question. What is the balance between district batteries and building level batteries, and what do you see being more prevalent as we move forward?
Maybe Mo, I can start with that, and then I'll kick it over to you. I mean, I think there's sort of a bifurcation a little bit between what is considered like a utility scale battery, which I'm kind of assuming is what you mean by district, and then a customer sided battery, which is typically 5 megawatts and below, and is something that can go through like the New York State interconnection process. And I think the prevalence that we're starting to see, at least on the customer side, is around either upsizing a battery or directly trying to do behind the meter battery to reduce that local load. And so, I mean, one of the considerations is both the physical footprint that you have of land space available to deploy a battery on. You know, we sort of mentioned some of the challenges with rooftop storage, but right now the New York City permitting agencies are sort of really looking at how they can both support ground, but also know that people are interested in roofs because there's more rooftop space available. You know, New York City real estate is equally as aggressive if you're trying to get a plot of land to put a 54-foot shipping container on. So I think one of the things that we're sort of looking at is how customers can either adopt what is previously mechanical space or a parking lot to sort of adapt that for a customer side system that can either be a front of the meter or behind the meter, but it's typically considered about 5 megawatts. And that's a lot of what people are starting to look at insofar as how they can actually deploy it for themselves. And then the utility is looking, I think, at what you're referring to as district level, which is really 5 megawatts and above and goes up to the bulk size, which is sort of what we actually put out an RFP for, which Mo had mentioned is the 174 100 megawatt site. Mo, do you have anything else to add?
No, I think you summed that up pretty good, Lindsay. I think the only other thing apart from just the technical or the form factor is also the interconnection constraint, depending on where you're actually trying to interconnect, what the potential impact could be on the system and what system upgrade will actually be required to drive that to a successful commission project. From another perspective also is really thinking about as it relates to buildings and more of the behind the meter installation. A few years ago, technology didn't hit the road. We're looking at large shipping containers, 40-foot form factor, 53-foot form factor with small energy density. Technology is start to make headways, and where we're at today is more modular design. There are certain companies that are really deploying smaller, more targeted type of energy storage system that are now have very good high energy density per container in a smaller footprint. And footprint could be as much as 8 feet wide versus the bigger form factor. So I think one important consideration as you think about deploying energy storage system is number one, really identify your use case and what makes sense. And then how does technology supports that? And then of course, as Lindsay rightfully alluded to, you know, where is the AAJs as it relates to these technology? How do we get that permitted? And what are some of the hoops that we have to jump through as it relates to UL 9540A or TM1, TM2?
Yeah, and just one question still on this topic is, are there any regulatory challenges right now for getting batteries into buildings? And do you see those changing perhaps with fire codes or concerns from the fire department about putting certain batteries into buildings? Do you see that improving or changing over time?
Mo, I can,
yeah.
Please, sorry, I can take this one. I think one of the things that sort of evolved over time is sort of how the cities have looked at a site-by-site evaluation versus now they're sort of looking at larger. So there have always been sort of rules, but it's sort of in the beginning, or at least several years ago, it was very site specific. There was originally NEC, which was the sort of first company that really got like more blanketed approval. And so you had UL standards that companies would sort of undergo, but there really was still very project by project evaluations. And that still is the case, which is obviously very prudent for fire protection and safety standards. But I think that there is a move a little bit more towards a standardization approach. So as Mo mentioned, like the FDNY has a TM2 process, which is actually the FDNY working with the vendor to ensure that the FDNY has full comfort, and then they sort of certify the whole system, as opposed to saying we're certifying this one specific site. There's also a lot of working groups that are trying to help move this along. I know NYSERDA and CUNY had worked together with this, but this is something Con Ed's been sort of helping shepherd projects along with. I don't know that there are necessarily barriers as much as there is several different moving parts that you necessarily need to be a part of, right? So, there's also zoning considerations. Are you in a floodplain? So I think anyone who's interested, if I could succinctly suggest, if you're interested in putting in an energy storage, I think it's really important to, speak to your utility. As Mo mentioned, interconnection is also a big consideration for any energy storage project, but also get a better understanding of sort of where are you actually citing this from a zoning perspective? What are the sort of ruling AHJ jurisdictions? If you're in New York City, that's the FDNY. If you're in a Westchester municipality, that may be, your own township, and sort of get a better idea of what the landscape is before you get super excited about the technology, because I think you can be really interested in it, but if you don't have an appropriate place for it, I think that's where we're sort of seeing a little bit of tension. But I believe that a lot of that is sort of getting ironed out now, because I can say, at least on behalf of the city, there's a really large interest in making sure that storage comes online. So they've been very supportive there.
Gotcha. Thank you. So turning to generally how we're going to meet these goals, what are your projections for future workforce needs to achieve what we're discussing today? Do we need training or knowledge or new skills to be needed?
Yeah, I could tackle that one. So this is something that is currently on my table here as I tackle utility integration of storage. We have a large amount of storage that's going to hit our books in 2022 that we're going to commission, and the talk of union jobs in clean tech has emerged. And of course, that goes without saying what necessary training and skill sets are we requiring. One of the things that we're actually targeting is really making a requirement on our battery manufacturers as we deploy the system to provide, given the COVID world, both virtual and in-person training modules on technology-specific switching, operation, and understanding of what the alarms and how to mitigate that. We're also looking to increase our workforce, starting with what we have in-house, getting folks trained and up to speed to do these types of handle these types of DERs, not just from a battery perspective though, but more on a balance of plant, right? As you interconnect these into your substation, your distribution grid, what additional or non-traditional infrastructure are you putting in, and what those switching requires, and how do you get those training from the perspective of safety first, absolutely, but also technical certification as you think about different voltage class and connection. So that's some of the things that we're actually thinking, but union jobs in clean tech is on the forefront of our agenda right now.
Definitely. Thank you. Okay, we have another question here in the chat. How do you see the rate structures evolving to support resiliency and the transition that we need?
Yeah, so from a rates and tariffs perspective, and this is very closely aligned with some of the other questions that are in the chat as well. I believe there was a question around location of system relief value, as well as what policies Con Ed would like to encourage to support transmission and market services or distribution services. And I think that these are all very much related. I think we realize that the traditional way of billing and crediting is antiquated in a lot of respects because we're moving into a much more dynamic world of what it means to need electricity or to have capacity or to be able to benefit the system. And so from a rates perspective, there are proceedings going on right now in the state around specific rates for EV charging. There's discussions around demand rates and those demand rate impacts on battery charging and the siting of some larger loads. There's some tariff discussions that getting into the kind of the market discussion that have been kicked off in New York State through REV, but more broadly throughout the country now in FERC Order 2222 around the ability to dual participate if you're a DER resource and get compensation from a wholesale market as well as a retail market. And that's something that Con Edison very much supports. We think that resources should be compensated for value to the bulk system as well as locational value in the distribution system. And a lot of work that's going on internally now is figuring out how to make sure that whether it's our standby tariff or if it's our beater crediting, retail level programs that are currently compensating resources do not preclude them from seeking additional value in wholesale markets, whether it's for installed capacity energy or any an assortment of ancillary services. And so we think that FERC Order 222 is a good start. We think that that dual compensation mechanism is something that makes sense. From an LSRV perspective, to directly answer the question that was in the chat, we do post our LSRV areas both in our hosting capacity web application as well as on our DG website that you can get to at coned.com. And we think that that's a smart approach to try to encourage and incentivize the generation to follow the load and to have some of these projects at least get additional compensation when they're sited in areas where it's grid beneficial. And that's something that's going to take a lot of time to perfect. Obviously, the amount of available space and sometimes the siting that is available for a project is not necessarily located in a part of the grid where the value proposition is the best for the distribution system. And so, you know, we're committed to having a lot of internal discussions with our rates folks, as well as the New York Independent System Operator, who obviously runs our wholesale markets, around, you know, how we can more adequately credit DERs that are providing, you know, real grid services versus DERs that need to interconnect to the system because we have overall goals that we have to meet through the CLCPA, but from a locational standpoint are not as beneficial as others that might be in areas of the grid that are strained, especially under kind of peak activity. So the rates in the markets definitely plays a big role into facilitating the right mix of load and generation in the right areas as we move towards, you know, the future of the distribution system.
Great, thank you. I think we've got time for one more question. So I'm gonna, one question we have into the chat, and I might try and wrap this into kind of a more, what role does Con Ed have to play versus some other players at the state level too. There's a question about, does Con Ed need to be owning generation resources in addition to kind of owning the distribution around the city? And I think that kind of gets at a question of what is Con Ed's role versus maybe the New York ISO or some other players that are kind of all working together to bring renewables to New York City, to improve our ability to distribute that renewable energy around and get it to customers. So I'll open it up to whoever kind of wants to answer that last question.
So I'll take a stab at it. And I think what I would say is that, you know, Con Edison sees our place in the larger CLCPA operation as the grid planner, right? That's where our kind of bread and butter is. We're best positioned to plan and operate the grid. As far as owning renewables, I think we do believe that there are some very specific use cases where it might make sense for us to do that. Obviously, some of the projects that Mo illustrated in his slides where it might be utility-owned land, and for a cheaper cost than traditional infrastructure upgrades, the utility could simply install a battery that's able to do, generation arbitrage. We're seeing in our areas in Staten Island now, we're starting to get, you know, some duck curves in terms of midday solar production versus the amount of available load. Sometimes it would make sense for the utility to install a battery at a substation to be able to kind of charge during the overgeneration and then discharge to meet our network peaks as they occur later on in the day. There's some rev, cutouts that have always been in existence around the utility being a backstop to own storage specifically if there's a market failure and the market is not able to come to fruition to provide a solution. We have carve-outs to be able to own, certain DERs to prove of a value to, lower and middle income areas of our service territory where, perhaps they're not, or they may be being underserved by the market, and the utility could step in and make sure that they're getting direct value from this transition to the clean energy future. So I think that's a nuanced question. That's more of a nuanced answer. I think that there are use cases where it probably does make sense for the utility to deploy that resource, but I would say that it mostly makes sense for the utility to deploy that resource for a specific consumer benefit or a grid operations benefit where we're uniquely positioned to operate that asset at a lower cost, perhaps, than traditional capital deployment. So So we I think are more focused in the near term on making sure that our grid planning and our operations policies are able to seamlessly interconnect the DERs at a rapid enough pace to meet the goals, regardless of near-term ownership, right? I think the gun went off and we're all kind of leaving the starting line, and I think we're just making sure that we are not, we are not a hindrance to the interconnection of any of these assets or the ultimate electrification of any of the the building infrastructure in the state. So grid planning and grid operations, I would say, is where we see our long-term kind of footprint being occupied.
Excellent. Thanks for that summary. All right. Well, we are at time now. I want to thank the three of you, Jared, Lindsay, and Mo, for all of your insights that you gave us today. I think Caitlin's going to come back up and close us out. But thanks so much, everybody, for being here today with us.
Great. Thank you, everyone. And thank you to Danielle for moderating today. I do just want to go over a few upcoming events for Urban Green. On May 25th, our Emerging Professionals Committee is putting together a program, Which Credential is Right for Me? So if you are a young professional, considering something like LEED, WELL, Passive House, or even G-Pro, Urban Green's program, you can join that to learn a little bit more. We're also doing a program on June 10th, What's Next in Office Reopening at NYC, which will be a panel discussion, which will provide guidance on the most important measures that offices should implement to welcome workers back and reassure occupants of their health and safety. And then finally, on June 23rd, we have our annual conference, which this year's topic is Climate Equity and Health, No More False Choices, where we'll investigate how we can optimize policy and building design for climate equity and health together. And experts will shed light on aspects of public policy that are most likely to provide sustainable, equitable, and healthy outcomes for all. So you can check out more about those programs or register at urbangreencouncil.org/events. But thank you again to everyone and have a great day.